The WSU Children's Center purchased a few 6-child strollers 3 years ago. One of the teachers there noticed some cracks that had formed on the fronts of the strollers, supposedly from impact with the walls and other strollers as they have been put away each day. These expensive strollers have presented a new safety issue, but the manufacturer has gone out of business since the Children's Center purchased them. Since the strollers can't be returned and the center can't afford to buy new strollers, a potential solution was found in the physics department, where there are students that can design innovative bumpers to place on the outside of the strollers. The following demonstrates our group's research, designs for the old strollers, and also recommendations for the purchase of future strollers.
The materials that we used in our first design were a low-friction cart, Ziploc bag, cotton balls, and duct tape. As shown on this slide, we decided to place the cotton balls inside the Ziploc bag and tape that to the front of our low-friction cart. The reason why we decided to use cotton balls and Ziploc bag instead of using other materials was because we thought that the cotton balls were going to decrease the impact of the cart against the force probe. The first trial was less than 20 newtons of force, which was the overall goal for the project. Our graph had a slightly different shape than some of the more forceful runs. It was wider, which shows that the impact time was longer. The overall force was less because the amount of time the force was applied was longer. The materials that we used in our second design are a low-friction cart, Ziploc bag, and duct tape. As shown on this slide, as a group we decided to not place any cotton balls in the Ziploc bag. The reason why we decided to take out the cotton balls was because we thought that if we replaced the cotton balls with just air, that it would create the effect that a balloon would have when it impacted the force probe. The graph was slightly wider than our first graph, and the force was slightly less. The overall force was even smaller because the time of force was applied longer than it was in the first trial.
The materials that we used for this design were a low-friction cart, duct tape, and an inflated medical glove. As shown on this slide, we decided to tape the medical glove on top of the cart with the fingers facing the force probe. The reason why we thought that this design would work better compared to our previous designs was since the material of the glove is rubber, it would convert kinetic energy into elastic energy, which would decrease the force of impact between the cart and the force probe.
Our graph shape was considerably different than our other trials. It was much wider and shorter, and the force was much less than either of our first trials because the time the force was applied was 3 times as long as our first trial.
We were faced with the task of designing a model for a cart that would cause a less forceful impact than the original design if it were to crash. This process could be used to develop a safer and better stroller. If we were to think about what components of the cart's design made it safer, we could implement those to a stroller. Adding additional padding, preferably air-filled elastic material, on the front of the stroller could help immensely. This would lessen the force of the impact if the stroller were to hit an object. In the future, when the Children's Center purchases strollers, we would recommend placing a bumper on it as soon as possible if the stroller doesn't have one already. We believe one with air-filled elastic would work best.
Save the strollers, save the children, save the world.